In this video, I want to discuss how to simplify complex rational expressions. The technique I'm going to be using is basically multiplying the complex rational expression by 1. However, I'm going to be multiplying by 1 expressed in a more useful equivalent form. So for example, if you needed to simplify 1/3 divided by 2, if you multiplied that expression by 1, that wouldn't change the answer. Let me multiply by 1, but I'm going to denote 1 by 3/3, which is equal. And so we know how to do fraction multiplication. So I multiply the top by 3 and the bottom by 3. So that gives 1/6. See that? So we ended up with a simplified version of the original expression. Let me do an example with variables. Suppose I had 1/a divided by a, and assuming that a is not equal to 0, multiply by a/a, and this time we will get on top 1/a times a, and on bottom we'll get a squared, and the top simplifies to 1, and so the answer is 1/a squared. So this works with variables as well as numbers. All right? Now, one question might be, how do I know what to multiply the original complex rational expression by? What form what equivalent fraction equal to 1 do I want to use? And you want to use the form that contains the least common denominator of all the denominators of your complex rational expression on top and bottom. All right? For the first example that I did, the only denominator was 3. So that was the least common denominator. Therefore, I multiplied by 3/3. For the second example, the only denominator was a, so I multiplied by a/a. Let's see a slightly more complicated example now. And think about the explanation I just gave for how to find the fraction to multiply it by, the complex rational expression. How about 1 plus 1/b minus 2/b squared all over 1 minus 1/b. Okay, there's a lot of fractions in that expression. And we know, as I said, we know that we could multiply by something that's equivalent to 1 without altering the answer. And we also now know that we want the fraction that we're going to multiply by to contain the least common denominator on top and bottom. Okay? So what are the denominators here? Well, let's see. We have b and b squared. The least common denominator of all of those denominators is b squared. Therefore, I'm going to multiply by b squared over b squared. Okay? So let me write out that, and then we will do the distribution. Okay? So distributing the b squared into the parenthesis on top gives b squared plus b minus 2. And on bottom we get b squared minus b. That's already a lot nicer than what we had before, right? However, it gets better. You can continue to simplify. Now you can try factoring. So the top you can factor to b plus 2, b minus 1. The bottom you can factor to b times b minus 1. and then you can cancel the like terms, and putting it all together we end up with b plus 2 over b. Okay? So let me repeat. You multiply by 1, that's safe, that's doable, but you multiply by an equivalent form that's equal to 1, that includes the least common denominator on the top and bottom. Okay, how about you trying one now? Would you please try to simplify this complex rational expression? Y over 10 plus 1/2 divided by y squared over 25 minus 1. Okay, so pause the video and try to solve this one. All right, I'll go ahead and do it now. So I hope that you first found the least common denominator. You focused on the denominators, and you saw that we had a 2, a 10, 25, and so you hopefully selected 50. So we're going to multiply by 50 over 50, and I'll go ahead and distribute right now instead of copying what I have. So that when I multiply the y over 10 by 50, I get 5y. When I multiply the 1/2 by 50, I get 25. And then likewise on bottom, 50 times the first term gives 2y squared, and then minus 50. All right, and then now I will factor that, the top and bottom. So on top I get 5 times y plus 5. On bottom I get 2 times y squared minus 25. But that can be further factored. Okay, and so now we can cancel the common factors. And so putting it all together, we get 5 over 2 times y minus 5. Now, let me do one more involving variables in the denominator, and I want you to try this one as well. So we'll close with this. 1 over 2x plus 1 over 3x divided by 1 over x squared. Okay, pause the video and try that now, please. Okay, so I'll go ahead and do it. So looking at the denominators, I see that the least common denominator is going to have an x squared, but don't forget the numbers. The least common multiple of 2 and 3 is 6. So for the least common denominator, I'm going to use 6x squared. And I'm going to put parentheses around the top so that it's clear that I have to multiply both of those pieces by 6x squared. Okay, and so now distributing, I'm going to get 6x squared times 1 over 2x, that gives 3x. And then 6x squared times 1 over 3x gives 2x. On bottom, 6x squared times 1 over x squared, we get 6. And so we've already made it a lot better, but we can combine like terms on top now and get 5x over 6.